It's going to be really fun. It's our first ever experiment with community calls, so please don't judge really hard on us. And I hope you really enjoy the process. So we have a sort of schedule for today. We want to talk a little bit about what we're building at DeepPavlov. We want to talk about our roadmap for the remaining time of this year, as well as what we preliminarily want to do for 2021. We also want to show you a demo of our Moon AI assistant that we built for NVIDIA GTC Fall 2020, showcased just yesterday. And then we would love to have a session of Q&A where we can talk about your experiences with DeepPavlov technology, what you want to build, what you would love to have in our systems, what kind of things annoy you, what kind of things excite you, and maybe what kind of stuff you would want to contribute to the family of our projects. So that's a plan. We will also publish a recording of this talk on our blog, and we also will publish a version of our roadmap to the blog accompanying this recording, so it will be available also in text format for reading. And without further ado, Misha and me, we will talk a little bit about DeepPavlov library and community. We're not going to use a lot of slides here, but there are a couple of them that I think can be useful for this talk, that might be useful for Misha. Misha, give me a sec. I will make it work. So the first thing is why we're building DeepPavlov and why we're building DeepPavlov Dream, the thing that we announced like about a month ago. And I think Misha can give short overview of our vision from the research side. Misha, your time.
Okay, great, Daniel, thank you. And so our idea is that usually when you encounter real-world problems in the field of conversational AI, and you need to build complex AI assistants, what you have, you need some kind of modularity, because it is just outcome of the structure of the task. It is not because, like, maybe we all like, I don't know, nice architecture, but here it's just a structure of the task requires us to build modular solutions. Because if you look at this picture, and you will see, and you see here that typically your company, then it has many touch points with the clients, and usually different modes of communications, there's different facets of interactions with the clients require different knowledge on the side of the system, different style of communication, and so on. And if it is a big company, many teams are working on different parts of your system. So this is why we decided that we need to have a framework for multi-skill AI assistants, because it's easy to decompose these complex tasks on the multiple components, multiple skills. So this is what we are doing. So here you can see that you can decompose this in terms of technology on few levels. So the top one is a multi-skill orchestration, when you need to synchronize all these different domains of interaction, and then you need to build conversational skills by itself. And to build these skills, you need NLP frameworks. And so what we're trying to do, we try to cover all these three parts of the spectrum. So here you can see near my face here, it's like cloud, it's our multi-stream orchestration DeepPavlov agent. Then we have these triangular mountain, and this yellow mountain is our library for conversational skills. It's our Dream, like hub, Dream agent, Dream assistant, which has some template skills. And to build these skills, we need these blue ocean of NLP models, which you see at the bottom of this picture. These waves, like blue waves of DeepPavlov core library, which we have right now, and which we have like as a tool for building pipelines for NLP models. So you take these pipelines, you pack them in the skills, and then you use these skills for your digital assistant. And this is not very interesting picture. You know, this is how everything is built right now. You have NLU, dialog manager, and natural language generation. And then next slide. Then you yes. So and then you are building your complex AI assistant. What you usually do, you have NLU and you have dialog manager, and then you start. You have like clear picture what you want to do, and you have clear understanding what features you want to use and what scripts you have for to pleasure your customer. And it's very nice. It's MVP stage, and then you ship it in production, and then you want to increase coverage of your bot, and you add more and more features, more and more scripts, and then you want to cover more and more and more, and so it's to have a better user experience. And then you have what so-called mature AI assistant, which is actually like not very good thing, because you have all this complexity, which is hard to manage. If you have like few teams working on your conversational assistant, and every team can add or remove some feature, can add or remove some script from your system, might be it's not very good, because they are all interdependent and they can broke things by shipping some features. So this is why we are doing our stuff. So in our vision, go back. Just look at the bottom part of the picture. So what we do, we say, you like doing MVPs. They are nice, clear, and understandable. So just continue to do them. You don't need to have all this complexity. Just solve your problems step by step, and then you can like produce some modules, which can be, we call them conversational skills, which can be integrated in the agent. And the agent just orchestrates these skills. And so if somebody did something wrong in its own skills, you can just switch it off. And then everything, all the rest of the system will work as it worked before. So you solve this problem of interdependence here. You have a nice modular scalable architecture. And even more, it's more interoperable. It's much easier to reuse, because as you can see here at the bottom of the agent, you see this default skill stuff, which means that some skills are the same for different domains. And you just take this as a default agent and just put in your skills, and that's it. So if you're building complex system, I think that this approach is much better than conventional. Sorry for wasting your time, actually. So next slide. But so that's how we see different parts of our, we call it something like an ecosystem. So we have DeepPavlov library for NLP pipelines. And with these pipelines, you can build conversational skills. And DeepPavlov Dream is like a set of different skills in our framework. We just started to build it, and then we will feel, and we will add more skills. And also, we will be very happy if you will contribute any skills to our default agent. That it will be great. And we see in the future that this DeepPavlov Dream part will be like an open platform for exchange of conversational skills. And we have DeepPavlov Agent, which is like a core of like an operating system for conversational AI, which orchestrates all these skills into the coherent digital assistant, which you can customize for your purposes. Next one. Okay.
Okay. Misha, thank you very much for giving an introduction. Misha is quite humble, actually. These ideas of building this ecosystem were in his head like for several years. And it was a fantastic opportunity for entire organization to participate in Alexa Prize competition. And the DeepPavlov Dream as a bot is something we've built as an open source version of what we've built for Alexa Prize in the beginning. I'm actually quite anxious to show you something. Give me a sec. There is a slide I've actually hidden, but I think it's a good idea to just show it, not maybe dive into absolutely all of the details, but still, you know, show the thing. Just to give you a perspective, and this is very important. When you think about chatbot platforms that you have today, it can be Rasa, it can be Core AI, it can be multiple things. They usually focused on very specific thing. It's called goal-oriented systems, where you have just like number of skills, and they all focused on capturing intent of the user, maybe slots, maybe form a fill the form, and call some action. That's about it. But when we think about big AI systems that can solve problems for large organizations, it's not about just building a couple of goal-oriented skills. It's about building lots of skills. And for that, you need solid architecture. And architectures that we designed at DeepPavlov is very interesting, because in many ways, you can think of it like your opportunity to look behind the scenes of how the real AI assistants were built before us and how they're built today. And this is an example of what was built for Alexa Prize. You can see lots of different components running inside a huge NLP pipeline here. And the cool thing about it is you can talk to this Dream social bot on demo.deepavlov.ai. And we will keep shipping part of this system to you in the coming months. We actually have some news about our roadmap, and I think it's a good idea to share some of them. I don't have slides for this, but I will publish the entire thing in the blog post later. But a couple of things. So we have plans for Q4, and we have plans, more preliminary plans for 2021. Our big goal is to make this entire social bot available to you as an open source repository. We actually have it right now, but it's right now a hidden repository in our GitHub organization. But at some point, we will open source it. But before that, we will continue updating, continue shipping new demos that will include more and more components of the Dream social bot, and they will be available to you. So you'll be able to come to our GitHub, grab a repository with demo, and build it in your own site and play with it. This is how we want to ship you things until you open source the entire repository. So repository will be probably shipped not earlier than 2021 because it's really huge. But one of the things we're going to ship very soon is a demo we made available on GTC Fall conference, like last day, like yesterday. It will have one goal-oriented skill, one retrieval skill that will enable chit chat. And I think we have a couple of folks who helped to build this demo here. And you will be able to ask questions to them later on. There are a lot of things here. One of them that I want to highlight is we have this Cobalt QA. It's something that was part of Alexa Price social bot. It's something that Amazon Alexa team provided to folks that participate in the challenge. It allowed us to ask questions to their knowledge graph and then get responses. Obviously, we don't have a chance to ship what they have built, but the cool news is we have KBQA model. It's the most popular model as far as we know today. And we will be able to ship a demo with KBQA skill later this year too. So you will be able to play with it. It's really, really cool stuff. We also will focus on shipping different kinds of components. So for example, one of the things we will ship is intent catcher. It is one of the annotators, and we will ship it in our library in one of the coming releases. And we also want to ship dev tools, lots of dev tools. So for example, we want you to be able to build goal-oriented skills using our GoBot framework. I think software engineer who built it is with us too here today. And you will be able to utilize Rasa configs to build goal-oriented skills using our GoBot framework, and then embed it into the DeepPavlov agent as one of the skills in this architecture. And that's like a very high-level perspective of what's going to happen in the coming months and in the next year. And there will be a lot of cool stuff happening that we will publish in the blog post later, either today or maybe in the coming days. Okay, let me now show you the demo of Moon AI assistant. First of all, a couple of things about it. We wanted to build a simple demo that would be relevant to what's happening today. We all live in global pandemics, and we have to sit at home, and this isolation is really, really something that kills us, destroys our creativity, our energy, and we felt that building a demo would be a good idea if it would be built about something that could help us to thrive during the pandemics. There was a fantastic movie in 2009 called The Moon. It was created by Duncan Jones. It's a fantastic classic sci-fi movie, and it had a fantastic AI assistant called Gertie. Gertie, you can see him on this slide. It's a physical robot. It's moving within the Moon AI base, Moonbase called Saranj, and helps its only astronaut called Sam to live and function over the 3-year span to care about harvesters that collect helium-3 on the backside of the moon. The idea of the movie was that Earth exhausted all of the energy resources and had to rely on helium-3 collected on the other side of the moon to power thermonuclear stations. So this helium-3 is collected, then sent using huge railgun back to Earth, and then this is how energy comes to a planet. And Sam is the only one guy who is living on the base. The idea is that if you want to build this kind of AI assistant today, it is actually very much a possibility. With Rasa or with Corey and other things, you can build something very simple with goal-oriented skills like status of harvesters or prepare broker for a trip or something like that. But if you want to build a whole Gertie, you need also to have chit chat, and you need to combine all of those components together so they would together build a coherent experience. And what we wanted to do is to emulate it with DeepPavlov Dream. So we decided to pick some of the components from our huge bot and build this small demo. And this is a very simple architecture of the demo. As you can see, you can talk by voice, or you can type text into the system. We have just a couple of annotators, where one is NVIDIA NeMo ASR and the second one is spell checking. Once input from user is entering the system, it's annotated and then is sent to skill selector. Skill selector is a very important component. It decides which kind of skills should process users' input as the next stage. In this particular demo, we did not build a custom skill selector, so all skills are invoked at this stage. But in a real scenario, like the assistant we built for Alexa Price, we had a custom skill selector which picked only some of the skills because it's quite costly to invoke like 30 plus skills at every single step, and it might be simply irrelevant. Now then at the skills level, we have two skills. One is goal-oriented harvester skill, and second is email-based chit chat skill. Once the responses are collected by agent, those responses goes to candidate annotators. In our case, we wanted to show emotion of AI assistant, what it feels towards user. And so we applied one of our classifiers from the big DeepPavlov Dream project and put it here. Then we built a very simple rule-based response selector, which picks the best response of these two skills, which is quite primitive in this case. And we only decided to implement custom rule-based response selectors. So give you an example and also to add some debug information for the system. And finally, we don't annotate any responses here, while we actually annotate responses as a big DeepPavlov Dream thing. And then we send that data to TTS and to application. Once this is done, user can talk to the system. To configure all things, you have to configure two pipelines, two files. One is Docker pipeline, which is not exactly a pipeline maybe, but just a config for Docker Compose, where you just have to enlist all the services you want to run. You can see agent here, which depends on Mongo itself, which is a database we use for agent. I have a couple skills, harvester maintenance skill and program Y, which is a chit chat skill. We have one annotator called spell checking. We have Nemo. And we also have rule-based response selector here. And we have annotator for responses from skills. We have just one of them called emotion classification. And to enable all of this architecture to work, we need to also configure agent pipeline. It's a JSON file. This is an excerpt from that JSON file. We have several groups of things that correspond obviously to this list: annotators, skills, candidate annotators, and so on. And each component can be connected either as a Python code, which is a native Python code, or as web services. In this case, harvester maintenance skill is a web service, is a microservice, and we connect to this through HTTP. So it's quite simple. Harvester skill is very simple. It allows you to ask about the harvester status and get the status of a particular harvester and prepare a order for a trip. So when our demo goes, when our agent goes to harvester skill, it goes to this API endpoint called respond. It provides full dialog information, and we capture data from human utterances, grab information that is post-processed by spell checker. We detect intents, then we generate response based on the database, and then we return the response to the agent. So it could further move it over the chain and give it back to the user. And chit chat skill is based on email. It gets lots of different patterns like assistant profile, greeting scenario, some topics, and that's generally about it. You can configure quite a sophisticated chit chat bot using email itself. So together they show you how we can build a very simple assistant that can have both goal-oriented and chit chat skills. Now let me show you the demo itself. I already prepared the demo. I hope I'm gonna have any problems here. This is the console. It will be small a little bit, so we could incorporate the application.
So you want to do it live, not recording.
Yes, I want to do it live. Yeah, Misha, I'm gonna do it live. I'm not sure if it's gonna work, but I'm brave. I'm brave. I'm gonna do it live.
Yeah, brave man. So
yeah, come on. Oh, okay. Give a sec. And now I was too brave. Give me a sec. Here we go. So what's going to happen? On the left-hand side, you can see the application. It's a very simple UI of Deepy. It has a face from the movie. You can type to it, or you can talk to it. On the right side, you can see my console. It's connected through SSH to the server where our agent and all the components are running. What's interesting here is that you can see how each of the components in the pipeline is working. Nemo is doing the ASR, agent is coordinating the entire conversation, rule-based response selector picks the best response, program-wise one of the skills. So you can see how the whole thing is working in the process. And now let me, how to put it, let me, I don't want to, but maybe I have to. Now, we believe in science. We don't have to believe in anything else. So let's be brave. How are you today? Okay. And then that's the demo thing. Let's try it again. Misha, you've been very much right. When you're so brave as we are, the demo is going to collapse. Give me 1 moment. Let me restart the demo thing.
I've seen many live demos, and like the largest portion of them failed.
Yeah, well, in that case, we also have a recorded video, so no worries. But I'm really anxious to show you the real thing. It worked right before the event, so I really have big hopes that it's going to work. Let it finish loading, and I can show you the demo thing. Okay, so imagine that we are an astronaut living somewhere. We don't know where yet, and we've been in crash. We've been in an accident. So we don't know where we are and what's happening. What do I do here?
When you arrived here, there was a little crash. You woke up here in the infirmary. You suffered memory loss.
Okay, so I hope you really heard the answer from Deepy. Have you heard it?
Yeah, yeah.
Okay, that's nice. That's nice. So we know that we are in an infirmary, but where exactly is it? Where am I?
You are in the infirmary in the Moonbase Serene.
Okay, so what's happening behind the scenes is that agent provides us a response. Then this response goes to TTS, and then TTS provides us with a real response here. Okay, let's do something interesting. This is crazy, and you might say that Daniel, you're crazy, and that's very much right. But I have interesting feelings about all this stuff. Give a sec. We can stop. We actually don't have even to stop anything. Let me close the app for a moment and show you that we can talk to different TTS service. We have another service that is really fun. So we need to use different ASR. TTS, sorry, TTS implementation. Find the references, and what we're going to do is we are going to use a different TTS. We have 2 TTS here. One is default one provided by Nemo, and another one is clone TTS. It clones the voice of the real AI system Gertie from the movie. This is an experiment. And I thought that it would be a little bit fun for us to watch how it's going to work or not work. But we have to be brave. Men have to be brave. And by saying man, I mean human. Okay, so it's running now. Let's continue. Who are you? Now what's going to happen is we launched Clone TTS. It's a second service. It's just jump starting right now. And it's a cool thing. It can clone any kind of voice. And in this demo, you will be able to play with it as well, in addition to Nemo TTS too. And
I'm Deepy. I'm here to help you in your everyday chores on the Saturday Moonbase.
so now you can hear, this is like Kevin Spacey's voice from the movie. We cloned it using one of the cool projects, open source projects we picked up like about months ago. And it's really fun. Okay, so those three things were actually a chit chat. We talked to program Y behind the scenes. Now let's do some goal-oriented stuff. And let's type for some difference. What is the status of harvesters? So program selected the answer. We have hypothesis, synthesizing the waveform.
The 4 harvesters, harvester 4 is full, harvester 2 is working, harvester 1 is awaiting repairs, harvester 3 is inactive.
So what's happened right now, we got the answer from harvester maintenance skill. And it detected the intent and it now responded to us. Now let's do experiment with slot filling. What is the harvester 4 status? And
the harvester 4
it's actually full. That's one of the reasons we didn't pick this clone TTS sync for the demo yesterday. But you will be able to play with it and configure it. Let's pick another harvester status just to see that it works as a slot filling, and slot filling works well.
the harvester 2 is working.
Okay, not bad. But let's get back to our scenario. So we feel really tired, and we want to be supported by Deepy. So let's say that I'm tired. And again, we're getting answer created by the clone TTS sync.
Sam, have a rest and be happy. How can I help you?
The fun thing here is not only we get a response from AI assistant, we also get a change of its face based on the emotion. Okay, let's get back to the goal-oriented scenario and say prepare rover for a trip. Because we still have to go to the harvester 4, which is full, and pick a canister with helium-3 from it and get it with it back to the base. And again, you can see how the process is working. Agent got the response from rule-based response selector, sent it to us, and we sent it to clone TTS, and
preparing rover 3 for a trip.
And we're getting the rover 3 for a trip. Cool. One last thing. So imagine we've been in this rover, we picked up the helium-3 canister, we brought it back to the Moonbase, we put it into the small ship, into the railgun, we started the railgun, sent the helium-3 canister back to Earth. And how do we feel? We feel really lonely. So let's say it. I feel lonely. And again, I'm gonna get the response.
Sam, it might help you to talk about.
There is nothing to talk about here, Deepy, because we feel alone and we cannot talk to Earth. What's happening on the Earth? And now my pronunciation killing me.
I don't have
No problem. Let's do it the same way. What's happening on this? This is again a chit chat answer, not from goal-oriented skill, but from chit chat.
I can only account for what occurs on this base.
Yeah. So, well, this is the end of the demo itself. And it was a live demo, as you can see. I even changed the TTS during the demo. So I hope you could see that that was a real thing happening here, not just a recorded demo. Okay. So it's going to be the next big thing. I think it's a good time now to chill and have some questions from you folks. And we're anxious to hear what you think of what we're working on and hear your feedback. I think the best thing, given that the like 21 of us here, is you can just raise hand and feel free to ask questions. I will pick one of the answers, one of the questions here, and reply to them. Be brave. It's Friday. Thanks God it's Friday. Be brave. Just to clarify, there are a couple of folks who helped to build this demo. There is Fedor Ignatov. Fedor, feel free to say hi to folks.
Hi.
And there's also Sasha Dmitrievsky, who helped to build the chit chat skill for the demo. Sasha, please say hi too.
Hi.
Cool. What else? Oleg, I'm pretty sure he should be here too. Oleg is the author of our goal-oriented goal-oriented framework. Oleg?
Hey, I'm here.
Okay. So there are some of us here. So feel free to ask questions. We would really happy to answer you. And if you are still shy, you can type your questions in chat. Oh, sorry, in chat box. I think we have one thing. So the first question is, thank you for the great brave demonstration. Thanks. And I tried the library some time ago, and the panelist question was, how can I deploy it to avoid so long response time? Misha or Fedya, who's going to answer? Who can answer? Or talk about it? Who is brave?
Nobody is brave.
Come on. We should be brave. Fedya, would you like to give an answer?
Yes, it took some time to me to find this question and read it.
But what exactly is question about? Is it about TTS, ISR, or any other model? Because actually, usually performance depends on the model.
Yeah.
You're using in your pipeline. Some models are very fast, another not very fast. So.
Yeah, Sergey, feel free to tell us what kind of model. Like here, for example. The longest response time here was from clone TTS, and it was because it was a research model, not a practical thing. That's a good question. As we continue talking, let me just stop our physical demo and change to a normal TTS to see that the responses are faster.
From your calendar, dinner starts in 15 minutes.
Okay, let me start it and we'll see things. Sergey, what kind of components, by the way, did you use before? What kind of models? That would really help to know. BERT classifier. Okay, BERT classifier makes sense. Misha or Fede, would you like to comment more?
Recommend to use GPU acceleration. It's only way to increase performance.
Our answer was sharp and close to the point. Okay, let's try it again. By the way, the demo thing. Who am I? 1, 2.
I don't have this information.
So the cool thing is we responded in about 1 second, as you can see. And the longest time that we actually had to spend was TTS sync because it had to generate answer. And this is the thing that's running on our GPU. We have NVIDIA GTX 1080 Ti with 11 gigabytes of RAM on board. And this stuff is working in the real-time thing, as you can see. But obviously, if you're going to run it on your CPU, it's going to take some time. As I said, it's fine. You're late and then it's out of the stream. If you still have any questions about DeepPavlov in general, feel free to ask. It's never late. Folks, keep asking. Maybe wonder about what kind of components we want to ship, or you have feedback about some of them, go ahead. If you want us to fix something, or you have a story of using some of the components and want to tell about it, go ahead. And silence. Mikhail Orzinovsky says, thank you for the demo. You're welcome. It was a lot of fun. If you don't have questions right now, what we can do is one of the things we can do. First of all, you can obviously always go to our forums or talk to us through Twitter or Facebook and ask questions as they're in there. Another thing what we can do is, I don't know. Oh, another question. So new to DP architecture, but what has evolved from the previous DP libraries to now to the Dream structure? Misha, you or me? Who's going to answer? Do you want to answer or do you want me to answer?
You can answer. I've already covered it in some way, so you just give another
way of explanation. Okay.
You will use another angle, so everyone will have like better picture then.
Okay, so how we evolved. So in the beginning, we had DeepPavlov library. DeepPavlov library can be seen as everything for conversational AI. You have components like annotators, like named entity recognition, sentiment analysis, emotion analysis, and so on, and lots of other models. Next, they have models that are more specific. For example, Squad for question answering, FAQ model, and GoBot framework. Third, you have integrations with systems like Yandex Alice, Microsoft Bot Framework, Telegram, and so on. With all of those things, you can build your custom conversational AI solutions, but the problem is you have to build orchestration of your conversational AI solution on your own. And with that, what we've added to the Dream architecture was, first of all, adding DeepPavlov agent. It's our conversational AI orchestrator. You can think of it as a custom version of Beastalk server or MQTT in a way, but just in a way. It's not just a generic message queue service. Where you can put all those components from DeepPavlov library together to build a complete pipeline. That's the first thing that's different. The second thing that is different is in Dream, we also have a number of skills that are goal-oriented and chit-chat based. And you can just grab them, put them into the configuration of the DeepPavlov agent, and then grab the whole solution, run it using Docker Compose or Kubernetes, and run on your hardware or in a cloud like AWS or something like that. So those are like two big differences that I think are important to highlight here. Hope that is given you an answer, but if you have more questions, feel free to ask. Again, this is our first community call, so feel free to say something or ask something if you feel that it's a good idea. Don't be shy. It's a very new thing for us.
And actually, for us, it will be very helpful and very useful if you can say like few words about your experience using DeepPavlov, if somebody use it, and what do you think about it, what you find good, what you find not very good. So just you can say whenever you want about it.
And actually,
please share your feedback. Right.
And in the middle, in the meanwhile, we got another question: how chit-chat system was trained? Sasha Dmitrievsky, I think you would love to give an answer. Would you mind?
Currently, chit-chat is implemented in IML scripts, so it's untrainable. It's easy to adapt for new cases, but it requires explicit rule writing in IML language.
Let me clarify, it's not untrainable. It just don't need training. The third question is, or the fourth question is, so it's correct to say that Dreamer structure should govern the overall planning of what and how components are to be developed for a conversational assistant project? Yes, yes, and third time, yes, you're very much correct. That's the whole point. That with DeepPavlov Dream, you can control the entire conversation pipeline from the beginning to the end. You can control which skills should reply. You can control what kind of response should be picked by the system. You can control how the response should be annotated and extended to your needs. So that's it. You're very much correct. While you're still preparing the questions, I can say one funny thing. It took us about 3 months to transition from the chatbot we created for Amazon Alexa competition to something that you can pick. Alexa, shut up. To make it available for you folks and demo DeepPavlov.ai. And one of the things we are super proud of is we've managed to replace the dialogued classifiers and their factoid skill. And those are the things we are going to ship in the coming maybe weeks, maybe months to you folks as one of the demos. So you'll be able to grab that skill and use it in your own demo. Okay, one more question. Is there a Google collab revealing the meaning of your top-level blocks like Dream and the previous one, GoBot? It would be great to play with them in the prepared environment. Great question. Let me start with the last thing, with the GoBot thing. Oleg, can you talk a little bit about it, please?
Yeah, hello guys. I mean, we have, like, if I recall correctly, we have 3 demos of GoBot, and I think that right now, the thing that was demonstrated is not built on top of the GoBot, but it is on our roadmap to build a like Deepy-like demo of GoBot. But in our demo, in like Deep MIPT DeepPavlov, there is an examples directory where there are 3 collab, like literally collab notebooks, showing what is a goal-oriented bot and how to use it and how to build simple or not that simple bot, but that's about the GeoBot. And
I think I can show something about that. Give me a moment. So when you go to DeepPavlov.ai and you go to GoBot,
Yeah, I forgot to say that we have dogs.
Yeah. It's now a bad idea to mention that we have dogs. We have this two demos for GTC2 format and for Rasa configs. I'm not sure if I have mentioned that, so I'm happy to say that again. We support using Rasa configs for building Go-oriented skills using GoBot framework. And there is a blog post and there is a tutorial notebook. So this is a tutorial notebook. Let it open. That's one that one of those notebooks that Oleg just mentioned. And let it open. Sorry, something. Okay, that's crazy. Let me do zoom out. Maybe, I don't know.
That's how GitHub renders notebooks.
Yeah, it's not our demo. It's not part of our demo. Okay, so this is a notebook. Go ahead. Misha, go ahead.
Yeah, I mean that it's easiest way just to put this link in Colab and then it will open this repo. But here you have batch and you can click batch.
There is a link for Colab too, yeah. So you can go to Colab and play with it. But while it's happening there, I shared the link in the chat. So you can see that you can play with the demo itself here, and it gives you some explanation. We have a couple of demos, a basic chatbot and more advanced chatbot that's based on our DTC2 restaurants domain chatbot. It's a long story. This is advanced chatbot. So we can play with both demos using Colab. And we have more Colab demos. At least we have more notebooks. Let me look. For example, GoBot tutorial. And it should also have a link to Colab, I think. So again, speaking of the Dream. So this is a great question. We don't yet have Google Colab thing with explanation of how to run Dream. This is something we will work on in the coming weeks. I'm not entirely sure that we're going to run it there, but it's a possibility. The point is to run Dream in Colab, we have to use a very specific way to launch it. This whole thing is several microservices together and then run them in the whole thing. But it's a possibility, so that's what we're going to explore and hopefully shape in the coming months or so. That's about it. Okay, one more question. Any capabilities for DP Dream to incorporate skills developed with other framework? Yes, and again, yes. This is a great question. DP Dream itself is based on the agent, and DeepPavlov agent, it allows you to build components written in any programming language. Let me go back to the slides. As you can see in DeepPavlov Dream, you have a pipeline. And in this pipeline, you can specify how you want to embed your components into the system. And these components can be connected through HTTP. And you can just specify which URI you want, which endpoint you want to call, specify what kind of data you want to provide to it by using dialog formatter. And then you have a response formatter that you can use to transform its response into something that the state manager method inside DeepPavlov agent will be able to read. So it's quite an opportunity, quite a possibility, and that's how we actually build the whole thing. Our different components in the big demo, the demo DeepPavlov.ai, they written different programming languages, different frameworks, different things, and they all work together, orchestrated by DeepPavlov agent. Any more questions? So I wanted to tell you about the demo, how we've built it. So this demo for Moon AI assistant, for Moonbase AI assistant, we built it in about 2 weeks. and it wasn't a full time that we spent on it. It was about 1 week. All we had to do was to adapt our chit chat skill to this small demo. And Sasha spent some time on it, and Sasha will share his experience in a minute. Then another member of our core Alexa Price team also added a goal-oriented skill for harvesters. It's a very simple skill. It's not yet built on top of goal-oriented, our GoBot framework, but it will be at some point. And then Fedya spent a lot of time just combining those things together with NeMo TTS and NeMo ASR from NVIDIA NeMo library, and also making that clone TTS thing work with the whole thing. It was a lot of fun. We had different voices. For example, we had voice of Scarlett Johansson, who was the voice of Her, Samantha from the movie Her. And we had like several other voices, some creepy voices, some cool voices. It was a lot of fun. And we built it like one week in like a couple days. It was a lot of fun. And in your case, you will be able to run this thing on your computer in a very short time. And I'm not going to lie, building those pipelines takes some time. And one of the things we want to ship later, maybe in this year, maybe in the beginning of the next year, is to further simplify the way how you can build those pipelines and debug the whole process. Because this is not like one service; it's the orchestration of multiple components together. Okay, any more questions? Ask anything, like what programming languages you can pick or other things. Okay, just wanted to share. I finished the last Fast AI 2 course excited with their top to bottom learning approach. It would be great to see something similar in education about NLP in Russian. Great question. Vasily, are you here with us? Vasily? He is here, but I'm not sure if he can hear us.
I'm here, guys. I'm here. Yeah, of course.
Okay, cool. Can you share some couple news about our deep learning course?
Our advanced deep learning course, you mean?
Advanced one, yes, that's the one. Who talks about the basics?
So it's basically a reading club for advanced students, for master students. Do you want to know something particular?
I think so. Okay, let me put it this way. So we have a course. We're running it each year, I think. Vasily will correct me if I'm wrong. It's in Russian. The course is in Russian. So if you want to learn about NLP and then use Russian language, you can join the course. And we can share details on our website too. Vasily is not that shy usually, but
yep, that's right.
Go ahead.
No, that's correct. Yeah.
Talk to me about Russians. Sharp, straight to the point, and no more other words. Okay. Let me know, folks, if any of you have visited our forums on forum.deepavlov.ai and asked any questions there. Raise a hand or write here. Feel free to do it. If you didn't have a chance to do that yet, feel free to do that. We usually answer very quickly to the questions, like couple days ETA, maybe faster, maybe longer, it depends. And usually folks from our team answering there, so it's very easy to get response from the core team. One more thing. When you look at DeepPavlov Dream, you might ask a question, and that's a very important question. What is the big future here? This is something I've asked myself when I joined Yandex a couple of years ago and worked on their Yandex AI assistant called Alice. One of the big problems of big AI assistants that we have in the market, like Alexa or Google Assistant and others, is there is a strict distinction between first-party scenarios like reminders or news or playing music and other things, and skills that are provided and built by third-party developers. And the problem is that you usually have to invoke skills by name, and then you have to talk to the skill. And this is a bit annoying and hard experience. And that's one of the problems that I think is plague of voice AI assistance market in general. And what is interesting is in the case of DeepPavlov Dream, you can add as many skills as you want, and users don't have to remember the name of particular skill to go into a particular scenario they want to talk to. To make this happen, you can control, let me go to the right slide here. You can control which skills to respond. The system can pick the response from, and then you can control the final response selection here in the rule-based response selector. And this is something that you control on the very bottom of the system. And this is something that is in your hands. So you don't have to let your customers struggle with this kind of experience. That's one of the things that I wanted to mention. And another thing is, obviously, when you have chit chat and goal-oriented skills combined together, that is also a problem. So, for example, at Russian Yandex AI assistant called Alice, it's a lot of fun. We built something called chatter, Boltalka in Russian. And you can talk to Boltalka, and then you can talk to other skills, other scenarios of AI assistant, and it would look very, very realistic. So you can ask it to set a reminder or set a timer or answer a question about, I don't know, some music, a movie or something like that. And then you can ask it about an opinion about it. And Alice would be able to handle this. Sometimes it doesn't handle very well, but it usually handles it. But when you go to Alexa or Google Assistant, they have very narrowed down set of things that those AI assistants can talk about. In our case, one of the things that we will share with the audience, with you folks in our blog, in our repository, and so on, is a plethora of chit-chat skills. You'll be able to grab them and use them, combine it together to support conversation, open conversation on any kind of domains. And this is actually a really hard task. It's a frontier for our industry. And it's a big challenge. It's a holy grail, if you want to think of it. And you will be able to grab those skills and implement this chit-chat experience for your customers in addition to goal-oriented skills. Another thing that is worth mentioning is there is a dialog state here in the architecture where all skills can share information with each other. This is also something that is usually very limited or not available in generic AI assistants like Google Assistant or Alexa. But in this case, you can share dialog state between all skills and push information from one skill to another. So for example, imagine that you have a skill that allows you, well, speaking of the harvesters, you can get information about the harvester status. And this is a skill that is controlling status of harvesters, where they are, what their status is, and you can say like stop or continue working, something like that. And then you can have another skill that allows you to automatically, for example, send rover to the harvester. And that can be a different skill. In this demo, it's like one skill, but you can have two different skills, each one responsible for particular vertical of your business. And then you can send information from one skill to another through the dialog state and let the dialog flow and let the system use this state to solve your problems in a very easy and transparent way for you. So that's another thing that is different from a typical experience when you build skills for big AI systems. I wonder if you have any more questions, folks. If you don't, we can have several more minutes and then wrap up for today. So you still have some time to ask questions. If you, for example, want to know how some of our folks build skills for Alexa Prize, we have several members of the team, so feel free to ask those questions. We have also Dima Karpov. He built coronavirus skill and book skill for Alexa Prize challenge, and those skills are also available in our public demo. So go ahead. Be brave. Okay. Thank you very much, Pre-Doc Technologies too. It was really cool to hear to get your questions. Folks, we are gonna run this community call once each month. Our current plan is to run it each last Thursday of the month, not Friday, but Thursday. So the next call will be this October on last Thursday of the month. If you are okay with this time, at the same time, so it will be 8 a.m. Pacific time and 6 p.m. Moscow time. Let me know if this thing works for you. If it works for you, we will just schedule the next call on end of this October. And this will be your venue to ask questions to us and share your feedback, learn about the roadmap, see demos, and maybe show demos. One of the things you can do in the next call is if you have a cool demo, you can just show it to the community during this call. So feel free to use chat to let us know if you find 8 a.m. Pacific on Thursday, last Thursday of the month is a good time for the next call. Okay, by the way, Misha is joining us back, and we're always fine. Cool. Okay, if you have no more questions for today, see you this October. Last day of the month, it's gonna be last Thursday of the month. It's gonna be October 29, and we will be back with you at 8 a.m. Pacific this October 29. Thank you very much for everyone for joining, for questions. And we can't wait to see you again on October 29.
Okay, nice. It was nice to see all of you and have your questions.
Yeah, I also want to say thanks to Oleg, Vasily, Fedor, Sasha, and Dima for joining us today.
And I want to say special thanks to Mara because she has her video on. I like that.
Mara rocks. She's the one whose smile actually gave me a lot of energy during this call. Thank you very much. Okay, see you next Thursday, last Thursday of the month. Goodbye.
Bye-bye.
Спасибо.